Now, for our next story, we go back in time. 12 months ago, we heard from Portsmouth Water in the UK about a project related to heat recovery from a local reservoir. They were developing a scheme to extract large quantities of heat from the large water body to heat a local housing development. Now, after we played that recording, a few of you contacted us to share similar stories, and we were particularly taken by the experiences in the Netherlands, where Tico Michels from Brabant Water encouraged me to speak with Andreas Moerman from KWR. Here are a couple of excerpts from my conversation with him.
So, I am here with Andreas Moerman from KWR in the Netherlands, and the reason I'm talking to Andreas is because a few months ago, we had Portsmouth Water, John Pickford from Portsmouth Water, telling us about the heat recovery they were doing, where they were recovering heat from a reservoir and putting it into a new housing estate. And shortly after that broadcast, Tico from Brabant Water rang me up and he said, "They're not the only ones who do that. We've been doing this in the Netherlands for some time." I was like, brilliant. Let's hear what they've been doing. Tico didn't want to talk to me, but he did say that the man we needed to talk to was Andreas. So, Andreas, it is wonderful to be connected to you. Let's start with, who are you? What do you do? Who do you work for?
Thank you, Piers, for this introduction. I'm Andreas Moerman. I have a background in civil engineering at Technical University in Delft. And I worked for a couple of years at KBR, more in the pipelines, the asset management, etc. But energy was still a very big topic for me and very interesting topic. So nowadays I'm working on really on the edge of energy and water. There's a couple of topics there, and as we call it in the Netherlands, thermal energy or energy recovery from drinking water whatsoever is one of the topics I'm covering. Yeah, and I'm project leader and researcher in that field.
Okay, so the Dutch Water Authority, I believe, is the sort of leader in this energy recovery from big bodies of water. What have they been doing? How long have they been doing it?
If I understood well from one of our drinking water companies, we have one example which really goes back to maybe the 80s. I don't know exactly, but what I know for sure is that already in the 90s, late 90s, we in the Netherlands had an example where we had a sustainable new village, part of the village which was built there, and they wanted an ATES system, so an energy storage in the underground to store sustainable heat in summer to use it in wintertime. But it was forbidden there to drill because it was an area where water was pumped out from the ground, so they could not drill there. They were really seeking for another sustainable energy source to deliver heat to a low temperature district heating system for around 200 dwellings and a couple of utility buildings. And so they came in contact with, at that time, Renewable Water, which is now Vitens, and they built there a connection with the reservoir there. So I think you can imagine the same example as you told in the introduction. Which is already working for.
Basic idea is that you've got this reservoir of water that's at a pretty steady temperature all throughout the year, maybe varies by 2 or 3 degrees. And so we use it for cooling in the summer and heating in the winter. Is that right?
In the base, it's heating in the winter. Cooling in summer is also applied, but that's of course, we don't want to heat the water in summertime. So if you want to use energy recovery from drinking water to deliver cold, then you need in between a seasonal energy storage, because then you turn it around and you heat up the water in the winter a bit and lower it in summer. Then you have a win-win situation. But that's not exactly the case in the case I was talking about. But we see also examples in the Netherlands in this combination with energy recovery from drinking water and this. I'm looking for a name. It's aquifer thermal energy storage. That's the official name for this.
Aquifer thermal energy storage. Got it.
Yeah. But that's a different topic. But it's it's really connected to the drinking water topic. But so we have for 20 years, more than 20 years, we have quite a nice example. 200 households is not that small, I think, and a couple of utility buildings.
And tell me, how does the economics work? Does a separate organisation own the heat network and then sell the heat to the houses? Or is it
in this particular case, that's the case. So there is it's not a business-driven thing. So it should be below zero in the end, but it's owned by the public. It's a local initiative, and it's owned by the end users of the heating system. Yeah.
Well, let's come to, would you do this again? Is this a good idea? Bearing in mind you've been doing this for quite a few years and you've got a lot of experience, is this a worthwhile project to do, or is it more trouble than it's worth? Imagine you're talking to a utility somewhere in the world that hasn't done heat recovery from its reservoirs, and they're listening to this thinking, oh, this sounds interesting. Is this a dance worth going for, or should you stay on the sidelines?
Yeah, it depends a bit on from which perspective, of course, you answer the question. To be honest, it's not something like a silver bullet. So we also calculated. We received a lot of questions about what's exactly the potential of this heat recovery from drinking water. Can it cover maybe half of the buildings we have? Of course not. So we estimate that it's around 5% of the total heat consumption in the Netherlands. So on one hand, the potential is not big, and we need a lot of other sources also to make this heat transition. But that's already another part of the answer of this question, that we need all the sustainable energy sources, heat sources we have to come up with to come through this heat transition.
The energy transition. Yeah, we need. There is
looking from the perspective from energy transition, we need all the sources we have, and drinking water it can be a very good source, because if you combine it with ATES, so with the aquifer thermal energy storage, you only have to deliver the disbalance of the ATES system.
As Andreas said, the amount of energy that it can be recovered is relatively small, just 5% of the total heat demand for the homes. But we need to be exploring all of these opportunities.